No matter what business you're in, digital transformation never stops. At Verizon, we keep companies ready for what's next. We weave security into their business, virtualize their operations, and build AI customer experiences. We also keep them ready for the next big opportunity, like 5G. Almost all of the Fortune 500 partner with us. When it comes to digital transformation, we're here and we're ready.
Hello, and welcome to 2020 Security Vision, Managing Digital Risk in the Era of IoT. If you're joining us live, our speaker is in the Slido chat discussion area right now answering your questions. For audio or video issues, please click the technical support button below. I'd now like to turn it over to Art Fontaine for the presentation.
Thank you very much, Britta. Hi, everybody. I'm Arthur Fontaine. I'll also answer to Art. I work in the solution strategy area at RSA, the part of the RSA company that's the product side, not necessarily the conference side. And I'd like to talk to you today about IoT, Internet of Things, specifically how it engages your risk and cybersecurity roles at your company, and some predictions about where things are going and what you can do to take advantage of those changes in the IoT market. So let's start with just kind of the market metrics. This is certainly one of the biggest market evolutions that's come along in a long time, certainly as big as cloud or even mobile. One of the things I like to point out that we're going to have 3 times as many devices as people on this planet in a few short years in 2025. And by that time, we're going to be adding over 150,000 devices every minute from the Internet of Things. Not surprisingly, companies are taking advantage of this. We're seeing a majority of them reporting that they have well-developed IoT initiatives, and most of them have IoT budgets. However, while there's a lot of benefits to IoT, it also brings into play a lot of risks and other considerations that we need to take a look at. In this report from the U.S. Congressional Research Service, we see that there's a concern about just the sheer scale and breadth of the categories of IoT devices. You've got major categories like the industrial Internet of Things, the medical things, smart cities, smart homes, each with thousands or even tens of thousands of different unique devices. That causes a lot of heartburn for your cybersecurity folks because it's very difficult to get a handle on all of those devices when they're not really standardized in any great way. Which brings us to the other side of this, and that's the policy issues. And this is what is going to engage your risk professionals in your organization. So the policy issues are around the regulation of IoT. You might find yourself in violation of some standard regulation or law. You also have digital privacy issues where you could find that you're losing private or proprietary data. And then, of course, you have the data security issues, in which case you might be hacked, and nobody likes to see that. So we have a poll question for you. We're going to invoke that now. I'm recording this ahead of time, but I'll be in the Slido chat so we can answer any questions in real time. The question I want to ask is, how involved are your cybersecurity and risk professionals in your IoT infrastructure? And the answer is yes, no, or I don't know. And I'm going to be very interested to see your answers in that. So at RSA, we look at the digital transformations as in context of the digital risks they create. Now, obviously, the positive digital transformation is that you're adding new features, function, capabilities, you're satisfying markets better, you're building better products, you're building better processes. Each of those, however, would bring you additional risk. So we think about, the cyber attack risk you might bring on with the digital transformation like IoT, the workforce risk, the third-party risk, the privacy risk, the cloud risk. All of these are the questions that the customers are asking us today. They're not so, talking about firewalls or blocking malware. They're talking about these big business problems that they want to make sure that they're addressing correctly in order to take advantage of the opportunity. And one thing about IoT, and again, I said it's as big as any of these, is that it will be something that's involved in all of your digital risks. So no matter what problem or what problem area you're attacking, there's going to be an IoT component of that. And one of them that you've probably heard of already is around distributed denial of service attacks, or DDoS. Most of us have heard about the Krebs on Security, DDoS, or the Dyn attack in 2016, where insecure devices, mostly cameras and DVRs, were recruited to have a DDoS attack on a particular target. We all know that the targets themselves are, typically suffering a lot of hassle, heartache, lost visibility. Customers are having problems interacting with these sites. But an interesting study from the University of California at Berkeley was around the other costs, the hidden costs that actually accrue to the folks who own and deploy and manage these devices. And they did some analysis on this. First of all, on the Krebs on Security attack, they found that over $300,000 in expense accrued to the folks who own those devices, irrespective and above and beyond what happened to the Krebs on Security website. And the Dyn attack, which was the same year, the Dyn DNS servers were all taken down, leaving the internet unable to reach many major websites for several hours. That attack cost to others outside of Dyn was actually a little less, a little over $100,000. They also have done a calculation where you can look at a worst case scenario. So in this case, they've taken a look at what could potentially happen if this same model of DDoS attack with hijacked devices were to take place, and they found that it could be up to $68 million. This is a very interesting report, and I would certainly advise you to, if you have a chance, to download it and go through it. You can also play with this calculator with some different variables to show exactly what the impact would be, again, not on the victims, but on the community of device owners when one of these DDoS attacks takes place. Fortunately, there are a couple of critical IT evolutions that are underway that are going to help clean up the hairball that we have right now in the IoT space, as well as position us in the future for a much more manageable and secure IoT foundation. The first is edge computing. And edge computing is an interesting concept we'll go over in quite some detail here. But what it essentially does is it puts a layer between the devices and the cloud services to which they're connected and to which they typically report, that gives you a lot of flexibility to do things you cannot do today, including get things under control and manage them. The second major evolution is around standards and frameworks. As we all know, IoT kind of grew up outside the IT and risk world, typically in operational technology or OT or industrial control systems or ICS environments that run manufacturing, that run distribution services, energy systems, et cetera. And many of them were purpose-built for a single application. And as such, the focus was on how to make sure that all of those applications run reliably with no downtime and deliver the value to the company. Things like manageability, security, certainly were thoughts, but might have kind of taken a backseat to some of the operational requirements of the systems. And the ability to apply standards and frameworks, both for manufacturers as well as folks who deploy these systems, is really of great promise to make the whole IoT world work a lot better in the future. And we'll talk about that going forward as well. So let's talk first about edge computing. In this chart from the IEEE, we see how the fundamental design of today's existing systems works. You have your IoT devices at the bottom, and you have your kind of command and control systems at the top. And each of these connects directly from the device to the cloud or data center application to which it belongs. And there's some good, certainly some good factors around that. One is that you can apply all sorts of administration, security, management, analytics at the cloud or data center level that attaches to the appropriate device. And you can do all sorts of data manipulation, and you can command things back to the devices themselves. And when you look at them individually, that's actually a pretty clean operation. The issue that arises and has arisen over the past several years is that as more and more of these systems are deployed in this kind of silo architecture, they don't talk to each other, and they kind of multiply the task of securing, managing, de-risking these things. And that's why typically they haven't belonged to the IT security or the risk functions, but to the operational functions that actually deploy, manage them, and bring value to the business. again, works great. The problem is being that it really has created a lot of complexity, and it makes it ever harder to gain control of them. So with edge computing, it's a different approach. What happens is that through a number of small but powerful gateway and server devices, you create a middle layer that's sitting out toward the actual devices at the edge. That's why it's called edge computing. And you are able to do some things that you can't do in the siloed model, specifically around creating additional processing and analytics at the edge, doing things like data caching, buffering optimization, again, at the edge, and particularly machine-to-machine communication. So in this case, you can actually integrate the devices and their applications at the device level themselves, not at the cloud or data center level. So it's a kind of on the ground or in the field integration that isn't possible today. When you talk about exactly what it looks like, the anatomy of an IoT solution and an IoT platform looks pretty much like this. You've essentially got your IoT endpoints talking to your IoT apps with the IoT platform in the middle. What that allows you to do is you can enable these core services such as data management, device management, discovery, security, risk management, right in that middle layer as a common layer across all of the different applications and services. And what it allows you to do as an open and extensible platform is to let vendors who do things well do the things that they do well. So if you've got a vendor who's good at discovering devices and inventorying them and knowing what their capabilities are, what patches they need, et cetera, that vendor can participate and contribute to the ecosystem, or multiple vendors can do that, and you as a customer could choose which vendor you want to use. Similarly, with security, you have the ability to add security at that layer in a very powerful way. And again, you could choose from multiple vendors to apply that level of functionality. So it really is important to be able to understand that this middleware layer is all about taking the previously separate applications and making them behave as one. Let's take a look at an example that I think, especially for the technical folks in the audience, will give a better view of what's going on in this case. So this edge platform architecture is one called EdgeX Foundry. It's an open Apache 2.0 driven project that's hosted by the the Linux Foundation, and it's available freely to anybody to use, and certainly available for any community member to contribute to and to enhance. So let's take a look at something that's not uncommon in the world of IoT, where you'll get an alert from a particular piece of equipment in the system. Now, this is all loosely coupled microservices, but there are some core services that come with the foundation that can be exploited directly out of the box or can be replaced with other versions. But when something like a temperature sensor detects that it's 102 degrees and that's out of the envelope that you would typically work with, then that alert would be sent from the device itself using, in this case, a BACnet protocol to the core data services layer, which then forwards it on to additional services and then onward to the application itself in the cloud. So you've gone southbound to northbound with that, but you've passed through the EdgeX Foundation platform to do that. Nothing that the system that has been installed sees is anything different than it's ever seen, and it really is just from the device to the application. But since you've run it through this middleware layer, you have the ability to do other things. And some of these things, as you'll see, are very useful. So in this case, one of the services that passively passed that information onto the cloud takes a look at this and says, hey, let's run it through the rules engine. Let's do some local analytics. And in doing so, they've discovered that the high temperature is due to one of the devices in the system, which might talk a completely different protocol, MQTT in this instance. We'll talk about that in a minute. And it turns out there's a machine that's overheated. Well, here, right in the application layer, in the middleware layer, you can automatically have the system using analytics shut off the machine that's creating the temperature problem. Whereas in the pure kind of traditional model, that alert would have gone to one system, and something would have had to happen up in the cloud or data center layer that would have taken that information, turned it into actionable intelligence, and caused something or somebody to go and stop the machine that's causing the problem. So as you can see, a simple kind of if-then command set can bring this whole loop closed and create much more value than any of these individual systems could have on their own. Now, since this is a modular architecture, you can add all sorts of capabilities. One of the beauties of the edge gateway and server architecture is that it's a place to put an agent. You really can't put an agent in many or even most pure IoT devices because many of them don't have the processing power or the memory to handle an agent without slowing down or potentially being impacted. And many of them are deployed in places in ways that you probably wouldn't be able to get to easily. So attaching those devices to the gateway gives you a place to put a very powerful agent if you want, and you can do things that are different than what you could do in the traditional model. So in this instance, we could apply a security monitoring agent that would also integrate with the rest of the application. And in this particular problem set we just talked about, talk to the core services as well as potentially other environmental external information sources, and then send that information off to a security cloud. And that security cloud could then look at this anomalous behavior and say, analyze it, whether it's something that was just a random failure or might be something that's associated with an exploit or an intrusion of some sort. So this is, again, this is passive. We're not getting in the way of the application or its performance. We're just observing what's going through and acting upon it if appropriate. And one example of this is the RSA IoT Security Monitor service that we've got to do exactly what we're describing here. But you could do this for any feature function, and you can do this with many vendors. It's totally up to the customer, essentially future-proofing your deployment because you can actually work with any vendor at any time instead of being locked into one of these, proprietary vendors with proprietary protocols. So very, very exciting stuff. So the second half of what's going on that's really important is this evolution of standards and frameworks, because initially, as I mentioned before, most of these products and services and applications were purpose-built, and they were necessarily engineered to the tightest possible standards to give you what you wanted as an application, not necessarily in context of all of the other things that you might want to do in your organization, especially around IT security and risk. So the emergence of these standards and frameworks gives us a layer of commonality that we're be able to take advantage of going forward, and really does hold the promise of cleaning things up. And I'll walk through a few of these to give you an example exactly of what they're delivering in context of what we're trying to do to, not just clean up the existing problems with all of these brownfield deployments or existing deployments, but to give us a roadmap on how to eliminate or minimize such inconsistencies and problems in the future and bring us to a world where IoT is, like IT, largely an integrated, manageable infrastructure. So the first one I want to point out is NIST. So the National Institute of Standards and Technology in the US has developed for manufacturers of IoT devices and systems a set of cybersecurity capability core baseline, as well as the activities that should take place for IoT device manufacturers. We looked at those digital risks before, and one of those is third-party risk. One of the third-party risks that customers are worried about is something being implanted in the supply chain, some malware or an extra chip on a circuit board somewhere implanted by a nation state. You never know where something might have been put into the system before you even got it. Well, companies that follow and conform to things like the NIST standards in this area are going to offer a much higher level of assurance that the devices and systems that you deploy haven't been hacked or otherwise compromised before they even got unpacked from the box. The next one I'd like to talk about is the MQTT. Now, this is the telemetry transport for machine-to-machine connectivity, and it's been around for a while, continues to mature. It's extremely lightweight. It's very useful for connections that are remote, that have a small code footprint, or where network bandwidth is either intermittent or at a premium. So it's ideal for these mobile applications, energy meters, distribution points for cable TV, et cetera, the things that are kind of out in the community that can't be easily physically touched or dealt with and have typically very low power. MQTT gives them a way to talk to each other. And as this is something that's supported by the Edge frameworks, it means you can do it at the edge instead of going back and forth to the server to do that. The next one is the OPC UA, or the Unified Architecture. And this is kind of derived from a long historical sequence of inter-application protocols, starting with the COM framework from Microsoft. And what it does is the Unified Architecture gives you a way and a platform to integrate all of these individual classic specifications into a coherent set of processes and designs that you can work between systems with. So again, really, really easy to use, takes a lot of things that are hard to conceptually, kind of grok and then implement, and give you a way to put them into place very easily with security and extensibility, for example. EdgeX Foundry, we talked about that. This is the open source project hosted by Linux Foundation. It's one of many. There are several edge platforms, including from the cloud service providers themselves. All of them have the same kind of design of getting the computing and the management and the security out to where the devices are and being extensible with products and services from different community members. So, this whole ecosystem of plug and play components really gives a lot of capability that we discussed earlier in this session, and empowering the people who deploy and manage IoT to, get control of them and secure them. So the IEEE has a number of standards. The draft standard P2413 for architectural framework is very useful. It defines that architectural framework and describes the various IoT domains, abstractions, et cetera. And there's a couple of sub drafts for smart city and power distribution. There could be more in the future. Again, these are just kind of larger conceptual frameworks that folks can kind of map their activities against and add coherence to what they're doing in the IoT world. The IIC, or Industrial Internet Consortium, has what's called the Industrial Internet Security Framework, or IISF. And this is, again, another kind of large, comprehensive resource for understanding how things are put together properly in the IoT world, including security best practices and the building blocks for security concerns, and an implementation guidance and techniques model. Importantly, it also includes an IoT security maturity model, or SMM. And what this allows you to do is to measure where you are and where you need to go in terms of the maturity model, very similar to some of the NIST maturity models for cybersecurity, where if you evaluate yourselves against what's really done well, you can find out where you are and where you have room to improve. So this is helps IoT providers and implementers understand where they need to be, and enables intelligent choices. FIDO, which is the identity group, has an IoT technical working group that's doing some very exciting things as well. And in the end game for this, you'll be able to treat, in many respects, your IoT devices like any other entity on your network with its own identity or identifier, unique identifier. And it will be able to provide device attestation and authentication. You can do some automation of your onboarding and binding of applications. You can do authentication provisioning. You can do access control. So you can say this application or device can only talk to these things and only do those activities. Again, locking down the capabilities of some of these devices and apps to a way that's consistent with best security and identity processes and lifecycle and governance as well. So ETSI and DDS have done a couple of things. The Object Management Group's data distribution service for real-time systems is a virtual global data space. So again, everything in that data space will be unique and interconnected. It will give you a place where applications can share, You can have quality of service parameters, including reliability, bandwidth, deadlines, resource limits, et cetera. Really kind of tune what you're doing with these applications and these devices. And it also supports the construction of local object models that fit into the global data space environment and kind of become a component of that automatically. ETSI has done something called the M2M, or the Radio Standards for Machine-to-Machine Real-Time Communications, that allows you to do things wirelessly. And conforming to this particular standard will open up a universe of other things you can communicate with without individual or kind of custom programming to make things happen, which traditionally has been a lot of the work that goes into one of these integrations, is making the things talk to each other. With the use of these growing body of standards, you really get a lot of that effort and time back. ISO IEC is another great one. So they've created these global standards and frameworks for IoT around information technology vocabulary, interoperability, both from a framework and a transport perspective, IoT use cases that you can study and conform to in terms of best practices. They've also got one on edge computing and another on industrial IoT. So these important emerging areas in how people are actually deploying these IoT systems. And lastly, the IETF has an RFC. And this is a kind of a really large, broad view analysis and investigation of the space, where it's a document that implementers and designers and authors of IoT specs, other IoT specs, including implementers, have a reference for details about security considerations, challenges, threat models, and mitigations. And this is really another great document to absorb and to conform to as you design your own systems and solutions. So all of these together, I think you'll agree, offer promise to clean up some of the traditional problems we've had in trying to do more than single things at a time with the IoT world. And they're very important. They give us a lot of kind of roadmap to where we want to be in terms of security, manageability, risk reduction, et cetera. And very importantly, you don't have to adopt all of them. I would say that if you've adopted one of them, you've improved your posture very greatly in your IoT deployment, especially around security and risk. So let's wrap this up. Just a couple of finishing points and recommendations that I'd like to leave you with. So again, we're talking about security and risk managers. There's a whole bunch of operational folks who are very interested in this as well. What we're trying to do here is to illustrate the value of integrating your IoT, not just as an operational activity, but within your organizational security and risk procedures. So I would urge you to make IoT part of your risk and security plans. Treat it like any other digital risk, like cloud, like mobile, like third party, like privacy, and engage all the right functional areas. This gives you a way to address the kudzu of freely deployed devices that are out there. Kudzu is a southern U.S. vine that tends to cover and engulf anything it touches, whether trees or poles or bridges or whatever. And, we have customers tell us that that's what it feels like. One anecdote is we were talking to a large manufacturing company here in the U.S., at Black Hat last year in Las Vegas, and one of the IT security managers said to us that he doesn't even know how many or what type of IoT devices are deployed in their environment because they've been pretty permissive about it through the years, and that the only way he can find out is to unplug something and wait for somebody to scream. And it's certainly no way to run a business. The other point I'd like to make here is that you want to empower your IoT use. Where you don't want to be is seen as the blocker or the thing that keeps people from doing what they want to do to improve operationally the business. So let's encourage use of IoT wherever and whenever appropriate, but impose security and risk review. And create a playbook that helps people who want to deploy IoT in an organization to get them to where they want to go without the friction of feeling that they're being restricted or held back in any way. And lastly, I'd like to just kind of tell you some points around de-risking IoT in general. Just have these questions in mind when you consider the topic. Do we have a handle on our current IoT deployments? Where do challenges exist today in the existing or brownfield device deployment? Are there any proprietary or siloed systems that you want to integrate? And sometimes the answer is going to be no here, that they just should exist in a silo where they are now. but in many cases, you'll find opportunities to integrate, especially at the edge layer where you can take advantage of having systems work together. Ask yourself, do we really know what's out there in our environment? Do we start unplugging things? You'll find that there's probably more out there than you thought. There's IoT devices in your coffee makers and your conference room TVs, right? So do you inventory those? Do you lock them down, and do you de-risk them? And then lastly, what is your strategy for future IoT deployments? Because it's very likely that the areas of standards and of edge are going to apply very quickly to you, and kind of shooting where the puck is. Heading where the puck is being shot is where you want to be there. So ask yourself, have we implemented or considered or investigated an edge architecture? And are we able to track and prove conformance to standards and frameworks, either individually using the frameworks or with our integrated risk products? That's what your risk team wants to do, is to take these things and plug them into their environment and make them manageable like any other risk in the organization. So with that, I think my time is up. I really appreciate talking to you today. If there are any questions, I'm in the Slido chat right now, and hopefully we're having a nice interaction. I'm Art Fontaine. Feel free to reach out to me or to follow me online at Arthur Fontaine. And I look forward to seeing you again next year, hopefully in person in Singapore. Thank you.